Hello everyone, my name is Sumit Maheshwari, working as an assistant professor in ABES Engineering College. Today I'm delivering a lecture on power factor improvement, and we are doing here a numerical on power factor improvement. So this is the numerical. An inductive coil 6 plus J8 ohm impedance is connected in series to a 100 volt 50 Hz AC supply. It is desired to improve power factor of supply current, which is unknown, and the power factor should be 0.8 lagging by connecting a capacitor. Now we have two choices. First, when we are connecting a capacitor in series, in another perspective, when we are connecting a capacitor in parallel. So we have to find out the capacitance in both the cases. So initially we have this circuit 6 plus J8, an inductive coil. So what is the power factor? Right now, this 6 plus J8, so we have Z, and Z is basically R plus Jx, then cos phi, which is R by Z, and the value of R is 6. And what about the Z? Under root of R square plus XL square. So this is basically 6 by under root of 100, which is 10, and this is 0.6. And in case of inductor, the power factor is lagging. So what is the meaning of power factor lagging? If this is the voltage V, so our current is lag behind with this voltage by this angle, so which is 53.13 degree right now. Now we have to find out the value of capacitance when we are joining a capacitor in series with this coil. So what will be the value taken by this circuit of capacitance so that our power factor should be 0.8, right? So this is the scenario. This is the coil, initial coil, and we are joining a capacitor in series. So what is the new power factor? Cos phi new. That is again R by Z new, because R is not changed. So what is the new Z? This is the new Z, which is 6 plus J8 minus XC. So put the value here. 6 divided by under root of 6 square plus 8 minus XC का whole square. So the new power factor should be 0.8. So we are putting here 0.8. So after calculation of this equation, we are getting 6 divided by 0.8, which is equal to 6 square plus 8 minus XC whole square, which is, and it should be square of this by removing this square root, so which is called 7.5. whole square. So after resolving this equation, we are getting 8 minus xc is equal to plus minus 4.5, or either we are making a quadratic equation in terms of xc. So we get the two value by taking positive 4.5, we are getting xc 3.5, and when we are taking this xc negative of minus 4.5, positive of 4.5, so we are getting the value of xc 12.5. So we have two choice, either we are taking xc 3.5 ohm or we are taking 12.5 ohm. So first of all, check which value we are taking. When we are taking Z 3.5, the Z would be 6 plus J 4.5. Put here X, the value of XC 3.5. So we are getting 6 plus J 4.5. When we are taking 12.5, the value would be 6 minus J 4.5. So in Z 3.5, the impedance is still lagging, but in case of Z 12.5, the impedance and the power factor would be uh, leading. So we cannot take Z 12.5. So we are taking only Z 3.5. Now we are calculating the value of capacitance. So calculation for C. So what is the value of XC? 1 upon 2 pi FC. For the C, which is 1 upon 2 pi F XC. We are taking XC 3.5. So this is 2 pi 50 into 3.5. After calculating, this value would be 9.09 into 10 to the power minus 4 farad. So in series of the coil, when we are joining a capacitance, so 9.09 into 10 to the power minus 4 farad is required. Now, when we are connecting a capacitance in parallel, so the new Z would be this 6 plus J8. It is like Z1, Z2 upon Z1 plus Z2 for this new circuit when we are connecting capacitance in parallel. So this is Z1. What would be Z2? Minus K J XC upon total impedance Z1 plus Z2, which is 6 plus J 8 minus XC. This is our new Z. So when we are taking the angle of this new Z, only we are taking angle. So angle of Z1 into angle of Z2 and the angle of Z1 plus Z2. So the complete angle we are taking here. So 6 plus J8, the magnitude is 6 plus J8. So the angle is 53.13 degree. When we are taking angle of Z2, so the angle in uh, when we are multiplying two polar angle, these are adding, and when we are subtracting, divising of this term, so we are taking in negative. So the angle of Z1 53.13 degree, angle of Z2 which is minus K 90 degree, because here minus JXC, and when we are dividing 6 plus J8 minus XC, so the angle is minus of tan inverse imaginary upon real. So which is 8 minus XC upon 6. So this is the angle of this Z nu. And we also said this thing, we are not taking here Z, only when Z1, Z2. So this is the impedance of this uh, new Z, and we are taking the angle of this term. So in this way, we are calculating the angle. Now, the new angle is given cos phi new is 0.8. So the phi n would be 36.86 degree. So here we know the angle, putting here phi new 36.86 degree. So when we are solving this, we are getting the value of XC, which is 28.545 after calculating this term. XC. Now we have XC, which is 28.545 ohm. So we are calculating the frequency. We are calculating the value of C, that is 1 upon 2 pi f XC. So 1 upon 2 pi into 50 into 28.545. So after calculating, we are getting the value of 1.1151 into 10 to the power minus 4 farad. So if we are comparing these two value of capacitance in series, we are getting the value 9.09 into 10 to the power minus 4 here. And in case of parallel combination of this coil, we are getting 1.1151 into 10 to the power minus 4. So when we are comparing, so it is just 8 times less capacitance is required when we are connecting capacitance in parallel. So the preferred method for power factor improvement is B, because we are required less capacitance of value. So in such a way, we are improving the power factor and calculate the value of capacitance which is required in any series circuit. Thank you. In next lecture, we are discussing some more numerical about this. This is disclaimer. Thank you.